Good morning. I'm David Chappell. Welcome to this talk on Geneva. Okay, so there's something very strange happening here at TechEd around Geneva. There are three, count them three, separate intro sessions to Geneva here at TechEd. One each day, Tuesday, Wednesday, Thursday, which is odd enough. But the other two were 300 level, which means you know some stuff going in. Mine, this one, is 200 level. I assume you know almost nothing about identity coming in. And yet mine is on Thursday, not on Monday or Tuesday or Wednesday. So this is kind of strange. But I don't really know how these decisions are made. They're not made by me. And so here we are. I'm curious, who has been in any of the other Geneva intro sessions this week? A few of you. I promise you, you're going to see repeated material. But I also promise you, I went to them too. I also promise you that my talk is just different. Because this talk, as you can see perhaps from the track code, ARC, this is in the architecture track. Architecture track talks are about what and why. They are not about how. And so this talk is about what Geneva is, what claims-based identity is, and why you should care. There are no screenshots, there are no demos, there is no code. This talk is all pictures, okay? With that preamble, to make sure this talk is right for you, all right? Let me tell you what this talk is really about. This talk is really about beauty. Because claims-based identity and the way it's embodied in Geneva is one of the most beautiful technical ideas I have ever encountered in my career. By the end of this hour and a quarter, my real goal is to make you have an aesthetic experience akin to seeing a great painting or hearing beautiful music, because really, this idea is simply beautiful. So, let's start. There are three things I want to do. I want to talk about the notion of claims-based identity. Remember, for those of you who've been in other sessions, this is a 200-level session. I'm assuming very little knowledge on your part. So I'm going to start at ground zero there. Once I've done that, and we have to do that, we just have to do that, because Geneva makes no sense without that, and you will never grasp the beauty without that. Then we'll look at Geneva. I'm going to walk through a bunch of scenarios, grasping why Geneva is so cool and why this technology it embodies is so beautiful requires seeing how it's applied in a bunch of different scenarios. So I'll do that. Then I'll end with a fairly quick look at a few more details about the Geneva technologies themselves. But again, the main thrust of the talk is really about claims-based identity, what it is, why it's beautiful, and how Geneva embodies it. Okay? So let's start with this big opening section. First, what is Geneva? Geneva is three things. It's a code name for three different things. The Geneva server. The Geneva server is the next release of something that exists already, something called Active Directory Federation Services, ADFS. All right? And I'll show you later how it expands what ADFS does. It expands it in a lot of interesting ways. It's also the next release of this thing called CardSpace. It was called CardSpace 2 for a while. It's now called CardSpace Geneva. Those are both new releases of existing technologies that expand the functionality in interesting ways. But there's also a wholly new piece in Geneva called the Geneva Framework. The goal of all three of these things is this. It is to help make this idea of claims-based identity real. So, the question we have to answer before looking at what Geneva is all about is, what the heck is claims-based identity? Well, first of all, what the heck is identity? What is identity? If you discuss this in a human sense, the answer becomes metaphysical very quickly. It's hard to answer. I don't know what that means. But in a digital sense, I know just what it means. In the digital world, identity is a very simple idea. Identity is just information. It's information about somebody, about some application, about some machine. Identity is just information. That's it. Now, most of the time, We care about identity information for users, people. And so for the rest of this session, I'm going to say user. But recognize that sometimes that can really mean machine or application. But most of the time, it is users. Applications care about identity. Some care more than others, but most applications care at least somewhat about identity information. They need it to do things like figure out who this user is, what they're allowed to do. Just a quick terminology thing here, as many of you know, I'm sure. The act of determining who a user is commonly called authentication, proving who you are. Deciding what you're allowed to do is commonly called authorization or access control. Those two words are largely synonymous. Never confuse authentication with authorization, different things. So applications need to do things like get your identity information to decide what you can do, make authorization decisions, and also to do things like personalize, to determine how they interact with you via display names or other things. So applications need to work with identity in most scenarios, in most cases. But here's the thing. Today, applications certainly can and do work with identity. But it's hard. It's hard. It's hard because there's never been any kind of overarching perspective, any architectural broad view that says, let's think about the problem of apps working with identity in the large scale, and let's solve it in a generic way. No. What we have is solutions that grew up from individual environments. And so you wind up today in your app having to deal with different technologies for identity in different situations. For example, if you build an application that runs inside a Windows domain, and its users are all inside a Windows domain, then for identity, authentication, conveying information, you're going to use Kerberos. Kerberos is part of Active Directory. It's built into Active Directory. And Kerberos lets you get these things called tickets from Active Directory, from the Kerberos KDC officially it's called. For your client, you then present the ticket to the app. Ticket contains things like your name and your group memberships. Okay? And that's great. Kerberos works really great for apps inside your Windows world. All right? Kerberos was the state of the art in 1984. That's how old Kerberos is. But still, Kerberos is part of the Windows world. Kerberos will be a part of the Windows world. In no sense is this claims-based thing I'm going to talk about here this morning a replacement for Kerberos. It builds on, it relies on, in some cases, we'll see, Kerberos. The problem is that Kerberos is great if both your users and your apps are inside a Windows domain, even a Windows Forest. Great. What if you build an app that is accessed on the internet? Your app has users, the great unwashed mass of users on the internet. Can you use Kerberos for that? Not really. Kerberos assumes a whole bunch of things that aren't true about internet users. On the internet, what do we commonly do? Username, password. Pick a username, choose a password. Great. That is totally different from Kerberos. What happens if you build an app that works inside your organization and you're then told, hey, expose that app to customers as well on the internet? Oh, what pain. You now get to potentially build this entirely distinct identity system with username and password. This is only because these separate mechanisms grew up independently. It was never designed this way. It's historical. It's an accident. And then there's a third situation that matters more and more. The third situation is if I want to connect an application in that organization to users in this organization, how do I do that? How do I give people in my company, let's say, access to a SharePoint site in a business partner organization? How do I do that? Well, the solution people prefer to use is called federation. But federation uses neither Kerberos nor the simple username password. Federation requires something else. Today, that mostly means, in the Windows world, a protocol called WS Federation and a token format called a SAML token. Is it Kerberos? No. Is it username and password? No. So your poor app that you built initially to work inside the Windows domain had to get hacked up to support username and password for the internet, and then when they come to you and say, hey, give single sign-on to users in our partner company. You then hack it up again, possibly, to use federation. This is just hideous. And it's just the result of history. This is not a designed situation. It's an accident. And it's ugly. And it's painful, worse yet. If it were merely aesthetically unpleasant, all right. But the truth is, it's painful, it's expensive, it's just no fun. We got to fix that. Wouldn't it be great to have one way for apps to work with identity that worked consistently in all of these cases? That is what you get from claims-based identity. Now, be clear. Claims-based identity does not necessarily replace all these mechanisms. They're still out there. But your app in this world, your app can be shielded from this diversity. So your app sees just one approach to identity. No matter what is being used at the other end, Kerberos, username, password, you don't care. Your app gets one consistent set of information about a user's identity. If there's any single overarching goal of Geneva, I believe, it is to make life easier for app developers. Let's talk about this. How does this technology work? I told you earlier that identity is information. You need some way to convey information on the wire. The way we do that is in this thing called a security token or just a token. I'm just going to say token. People often say security token as well. I'm going to say token. A token is a bunch of bytes. It's a bunch of bytes that contains information about somebody, typically. The token, as my picture indicates, is digitally signed. The issuer, about whom I'll say more in a moment, creates the token and digitally signs it. This lets the receiver of the token verify that it was not modified in transit and know for sure who actually created the token. That's important. So what's in the token? What's in the token is information about a user, typically. That information is divided into some number of claims. Claims. So for example, a claim might be your name. A claim might be a group you belong to. A claim might be your age. Claims. Each token contains information about a user that is claimed to be true by who, I'll tell you in a minute, divided up into these little chunks. Okay? And they're all digitally signed. Where do tokens come from? Who creates tokens? To start with, you might say, who stands behind the truth of these claims? They're called claims because when the application gets the token, what it knows is that these things are claimed to be true about this user. Are they really true? Well, the app can decide. It decides based on whether or not it trusts the thing that stands behind the truth of those claims. That thing is called an identity provider. Identity provider is an authority that makes claims about an entity, such as a user. What are some examples of identity providers? Well, a very common one is your employer. When you get a Kerberos ticket inside your company for an application, that ticket contains kind of the 1984 version of claims, okay? Your name, your group memberships. When the app gets that ticket, it believes those things are true. Why? Well, it believes they're true because this thing came from Active Directory. And getting an account in Active Directory requires, I'm guessing, that your administrator actually give you an account, which requires being an employee or something. Your employer is effectively the one who stands behind the veracity, the truth of those claims. That isn't always true, however. That isn't always true. Think about the internet. On the internet, the identity provider is most often, not always, most often, you. It is you. Think about this. You go to Amazon, for example. Pick any e-commerce site. They have you choose a username and a password. You choose a username. Does Amazon actually believe that you are that user? If I choose the username Angelina Jolie, does Amazon assume I'm a famous, beautiful movie star? They do not. Probably a good thing. All Amazon wants to do is have a unique identifier that it can use to know I am the same user every time. So that's interesting. The information an app gets inside your firewall is important. It knows who you really are. It knows what groups you really belong to. With username and password, that basic data information is really simple. All the app can do is learn that you're the same user each time. To learn about you, your name, your credit card number, it must ask you separately. Okay? Very different perspectives here. We're going to see the claims-based approach unifies this stuff. Great. Identity providers are authorities, organizations, or you in some cases. They rely on software called an STS, a security token service. An STS is software. The STS is what actually spits out the tokens. To ask an STS for a token, use a protocol called WS Trust. This is really important. I haven't said this yet. It's a fundamentally important fact about this beautiful technology. Microsoft, it's fair to say, was the leader in defining this stuff. They were the leader. Not the only player, but the leader. But what I'm going to tell you about today is all based on multi-vendor standards. It all works across platform and vendor boundaries. It is not a Microsoft-only solution. Were it Microsoft only, it'd be a lot less interesting. Still kind of interesting, but much less interesting. The fact that it's multi-vendor is hugely important. Okay? There's a company called Burton Group. Burton Group is an analyst firm. They are very strong in identity. I spoke at a Burton conference a little while ago, at which there was a large meeting of identity people, 300 people in the room, end users, vendors, and so on. This is like 2 years ago, year and a half ago. These are the cognoscenti for identity in the world. Up on stage came a guy named Kim Cameron. Kim Cameron is Microsoft's identity architect. He's the guy who is most commonly credited with a large share of the thinking behind these ideas. Kim walks on stage, and this audience, 300 people, end users, competitors, Oracle, IBM, Kim walks on stage, and the audience bursts into applause. And the reason they did that was because, yes, this is beautiful, and yes, it's multi-vendor. And Kim was the guy who led both of those things. Kim insisted that this not be Microsoft only. So it's a huge win here. Microsoft tells this story most loudly, but it is not just a Microsoft thing by any means. Also, in the claims-based world, it is possible to use any of a number of different token formats. There's no required way to represent a token on the wire. But it turns out that practically, pragmatically, for this to actually work, people have to agree on a token format. And so by and large, with Geneva, this is always true, pretty much. The token format is this thing called the SAML token. Now, don't be confused. If you follow this space, SAML defines a protocol and a token format. What I'm saying right now is we're using the SAML token format. The protocol is a separate topic, which I'll return to briefly later in the talk. But right now I'm saying, in the main, people doing this claims-based stuff use SAML tokens. What are they? They're just XML documents. Little XML documents, or maybe big ones, but they're XML. All right, here's a picture. You're a user. You're in a web browser or perhaps some kind of client. This is not a browser-only technology. You can have a browser, you can have a smart client using web services or something else. You talk to the STS. You prove to it who you are. You authenticate yourself. How do you do that? The answer is, it depends. As I'll show you later, inside your domain, you might well use a Kerberos ticket to do that. This thing does not replace Kerberos. It builds on it. On the internet, you might use username and password to do that. You might use a smart card. There are various options, but somehow you authenticate yourself to the STS. The STS then looks you up in some account attribute store, like what? Well, one big important example is Active Directory. Is it the only example? No, but it's a big important example. Looks you up, it finds information it needs in there to create the token that you're asking for. That token has claims in it. It then spits back the token with the right claims. I don't show it, but it's signed, of course, by this STS. You now have a token that you can supply to an application. Great. So here's how it works. You get your token. And by the way, a note about these diagrams, of which you're going to see many in the next hour. In each one, I'm going to be leaving out the stuff I showed you in the previous one. So step 1 there, get token, actually means authenticate to the STS. STS goes to the account attribute store, gets information, builds the token, sends it back to you. That's all hidden inside step 1. I'm going to elide that stuff for clarity here. But it's all still happening. Okay? So you get your token. You then can supply your token to an application. Great. Now, what is the app going to do with the token? Well, it wants to use the claims, obviously. But before it can do that, it's got to verify that this token really is from an STS it trusts. It's got to check the signature of the token, compare that against a list of trusted STSs, and then if all is well, it's got to crack the XML, spit out the claims in a format your app can use, like a class, for example. Now, one could imagine that you could write code for that over and over and over and over in your own apps. You could do that. That would be stupid. It makes a lot more sense to have some standard library to handle that stuff for you. Let's assume we have that. As I said, what it's going to do is the library can verify the token signature, and then it can check to make sure that this token was issued by a trusted STS. If you send in a token from some STS this guy's never heard of, it's going to reject you. You had to configure the app to get this going here to have the right trusted STSs on that list. But assuming that works, the app now can happily use the claims in the token. All right. So we are now seeing the first parts of the beauty. It's going to get better, I promise you. But the first parts of the beauty are evident, I think, here. Notice what the app is not doing. The app is not authenticating you. The app is not the one that cares whether you use Kerberos, username, password, smart cards, whatever, to prove who you are. No, that's the STS's problem. The STS authenticates you. The app, regardless of how you were authenticated, Kerberos, username, password, whatever, just gets a token with claims. All the app has to do in every situation is check the signature, make sure it trusts the STS, and use the claims. Right away, there's some beauty there, right? Because I earlier talked about the case where you've built your app inside the domain to use Kerberos, then you've got to add username, password, yuck, then you've got to add federation, double yuck. Your app had to change in all those cases. I'm going to show you the next section. To do all those scenarios, your app stays just the same. Your app stays just the same. Your app always just gets a token with claims. Great. That's very nice. Oh, hey, how about this? Exactly what claims are in that token? What claims are in there? Let's talk about claims, because claims are important here. Why are claims an improvement to this whole story? Today, for identity, what does an app typically get? Well, with Kerberos, as I said, you get a user identifier, a SID, for the user, and group memberships, SIDs. That's it. With username, password, you get almost nothing, right? Think about the Kerberos case. If I have an app, I get a ticket, I know the username, I know the groups. But it's very possible that I want to know more about this user. I might want to know, for example, their display name to personalize interaction with them. I might want to know who the person works for, who their boss is, to make an authorization decision, or what department they're in. Great. Today in the Kerberos world, how do I learn this stuff? The answer is my app goes to Active Directory. I can do this. I can access Active Directory and pull this stuff out. Great. To do this, developers have to use this thing called system.directory services and bite off the beauty, that was sarcasm, of that interface and LDAP and all that. Anybody ever done that? Anybody use that? Oh, a lot of you have. Was it fun? Did you say, I want to do this again, I can't wait? Right, you did say that, sir, you are, let's talk later, okay? That's very sad. That was just a joke, I'm sorry, right? It's not actually sad. Anyway, most folks don't like that all that much. With the claims-based approach, all this stuff is delivered to you. It's delivered to you, okay? The app just gets what it needs. You can set things up such that whatever the app needs, the user's display name, for example, who they work for, their department, can all be in the token that you are delivered. So what does this mean? It means the following, and okay, this is a point that people often think is not so beautiful. It means that when you install the app, somebody has got to configure the STS. We're going to see that probably means Active Directory in the Geneva world. Configure the STS to know that for this app, when you're asked for a token, put these claims in the token. You've got to configure to do that. Okay. As an app developer, that's kind of nice in some ways because it's somebody else's problem. You don't have to write the code anymore to go access Active Directory. You could instead just get those things supplied to you. So that's kind of nice, but nonetheless, recognize there is some of that effort in there. All right, what else? Claims are a really general idea. A claim can be anything, pretty much anything at all. So, for example, a claim might have your name. A claim might convey group or role memberships. A claim might convey personalization information, like your display name. A claim, and this is very cool, a claim might grant or deny the right to do something. Suppose I set things up such that depending on who the user is, I have arranged the STS to spit out tokens that contain a certain claim only if that user has the right to access, let's say, my data in my app. If I do that, my app can just look for the claim. Is it there? Let them access. If it's not there, they don't access. I can push the access control decision, the authorization decision, off to the STS. Is that useful? Maybe. I'll come back to that because Geneva lets you do that. I'll discuss it in a few minutes in various situations. So that can be useful. A claim can even potentially define constraints. You can imagine a claim that says this user can issue POs up to $1 million. Claims are really general. They can be pretty much anything. And the information in those claims is supplied by this database that the STS has access to. And we're going to see in Geneva that most often means Active Directory. In the general case of claims-based identity, it can be all sorts of things. Even in Geneva, it could be SQL Server or something else. It need not be AD. But it most commonly is going to be AD. One more thing. I have talked here as though users have only a single identity. As though you want to present the same information to every app you talk to. Is that true? No, it's not true. It is not true. The truth is that users have different identities depending on what app they want to talk to. It is very much analogous to the way we identify ourselves in the world today. Next week, I am going to Slovenia, Ljubljana, Slovenia. When I cross the border into the EU, they will insist I provide them with a token called my passport. That token has an issuer, identity provider of the US government. It has claims like my username, my name, my citizenship, my passport number, where I was born. Those are claims in my token I provide in that context to the border guard. I live in San Francisco area. If I'm stopped by a cop for speeding, which never happens, but if it did happen, okay, he would ask me for my passport? No, I couldn't do that. My California driver's license. which is a token issued by a different authority, the DMV of California, that contains other claims. My name, yes, but also my birth date, that I need corrective lenses, my gender. You've got to provide the right stuff from the right source in different situations. That's true here as well. That's true here as well. And by the way, my driver's license is a great example of why these things are called claims. They're called claims because someone asserts that they're true, right? My driver's license, if you'd like, come up out, I'll show you afterwards. My driver's license for sex says F. California thinks I'm female. They made the mistake when it was issued 10 years ago. I've never actually changed it. It troubles my wife. She thinks it might get me in trouble sometime, but I don't know. To wait in line at the DMV to fix this small change seems pointless to me, but it is a claim that is simply untrue on my license. Anyway, so you need to have different identities, right? To have different identities in this world means to have, probably, to have different identity providers, analogous to the California DMV, the US government for my passport, and so on. So, I'd like to have some way to let my users effectively work with multiple identities. They have to be realistic here. So, the way this works is like this. Your application can actually go talk to an app. Its first request from a browser or a smart client of some kind, web services, whatever, and say, you know what, app? What do you need? What providers do you trust? What claims do you need? And the app can tell it. It can tell it in HTML. It can tell it in a spec called WS Security Policy. There are standards for this, again. Once your app knows this, it can use an identity selector, some software in the client system that lets you, the user, choose an identity that matches these requirements. The selector typically has some kind of UI where you pick a picture of something. I'll show it to you later in the Geneva world. That maps to an identity. Once you've chosen this, you can then go to the STS that maps to, get the token. Again, in step 3, you actually authenticate and get the token. Then supply the token to the app, which uses the token, which uses the claims. All right? So, there you have it. Claims-based identity in a pretty small nutshell. What are you seeing here? You're seeing that there are 3 important things. There's the STS that issues tokens. There's the library the app uses to process tokens. And there is the selector that we use to choose an identity. To make this thing real, we've got these 3 separate things we have to have. With me so far? Well, gee, on my very first slide this morning, what did I say Geneva was? I said Geneva was 3 things. So, watch closely. Whoa, same picture, except now I've plugged in Geneva in those 3 slots. The Geneva server implements an STS. Card space Geneva is an identity selector. The Geneva framework is the library we need to make it straightforward to build applications that work with claims. Now that we know the basics of claims-based identity, and we know the fundamentals of how the 3 parts of Geneva fit in the picture, let's talk more about actual scenarios. Before I do, though, one more thing. You know, CardSpace was released a couple of years ago. I'm curious, has anybody in the room ever used CardSpace in a production situation, a production scenario? Anybody? I see no hands. Okay. When you look at this picture, you realize perhaps why that is true. Microsoft released CardSpace into a world that had no STSs and no identity library. So there was no way to build apps that use this stuff easily, and there was no way to get tokens unless you built your own STS. So CardSpace has been out there for a couple of years, but it's been kind of lonely because without other pieces, it has limited value. Primary goals, as I've said before, of Geneva are to make this whole vision real by providing all the parts that you need. Now, again, realize this is all standards-based. So in this picture, I could replace, let's say, Geneva Server with a Tivoli product. IBM's Tivoli division provides an STS as well. There are alternatives to CardSpace. There's the Higgins open source implementation, for example. So again, do not be confused. Don't think this is some Microsoft-only thing. It is not. However, this is Tech Ed, talks about Geneva. So throughout this presentation, I'm going to use Geneva as examples. But recognize there is no necessary connection among these three parts. You can swap out different vendors' things. In fact, if you were in yesterday's Geneva session with Stuart Kwan, they showed a demo of SAP in the application space, fitting in with this. And SAP, in that case, did not use Geneva Framework. They did their own stuff. So there's no way in which these parts must all be used, all Microsoft. Very important point. Now that we know this, let me go back to the different ways in which we might use this technology and walk through some core scenarios. Excuse me. Well, let's start with Geneva and the enterprise. Imagine you have an organization. You've got a Windows forest domain, whatever, and here it is. You have your user who wants to access an app inside this Windows domain, this single Windows forest. What do you do? Well, when the user first shows up, they log into the domain with Kerberos, like always. This is just how your world works. That's not going to change. Nobody's saying that Kerberos goes away by any means. When you do that, you get your Kerberos ticket, your initial login ticket. I'm eliding a whole bunch of Kerberos detail here. What I really mean is you get a TGT, which later on you use to get an actual ticket to talk to the app. But let's not get that detailed. Then what? Suppose that you want to access the app I'm showing here on the right. What do? You talk to it, and you say, what do you need? What STS, what identity provider do you trust, and what claims do you need? It tells you. You then choose an identity that matches those requirements. Let's stop right here. With CardSpace, you can have the CardSpace screen, which I'll show you later, pop up all the time. So users always have to choose an identity all the time. Turns out this is kind of dumb, because inside the enterprise, it's often the case that you want to use the same thing all the time. And so you can configure in policy, an administrator can define policies such that when a given user accesses this set of apps, they always use this identity. You can push those out from Active Directory. So if you do that, the user won't see the CardSpace screen pop up. Step 3 is left out. In all my diagrams, I will explicitly show choosing identity. But recognize that with CardSpace and Geneva Server and AD, you don't have to do this necessarily. It can be configured away if you want to. We got identity. We then go out, talk to the Geneva Server. We authenticate ourselves. Remember how this works. You authenticate to the STS, not the app itself, to the STS. How do we authenticate? Inside the enterprise, use a Kerberos ticket. That's how we prove who we are to the STS. The STS says, OK, I buy this. We ask for a token for the identity we chose and for the app we're talking to. Tokens are app-specific. They have to be, right? They contain claims that have meaning for that app. OK, sometimes the same token can be used for different apps. But in general, in the abstract case, tokens are app-specific. OK? We get our token. But first, in step 5 here, Geneva Server has to go build the token. How? By digging the claims out of Active Directory. If you follow this space, you know that in Windows Server 2008, Microsoft renamed Active Directory as Active Directory Domain Services. So it's now officially called ADDS. But I just can't make myself say that. So I'm going to say AD all the time. But my slides, you'll see, follow the official naming. If you're interested, we get scrubbed for these talks, right? So they go through our decks and look at these things, right? Sir, I can't do questions. I'm sorry, at the end. Is that OK? Sorry. All right, so we get what we need from Active Directory in this scenario. I'll show you later. You don't have to use AD, but in the enterprise case, you probably will. We build the token, we send it back, give it off to the application, which processes it, checks the signature, and uses the claims. Great. Why is this better than just using what we do today, just using Kerberos? Why is it an improvement? Well, as I said earlier, one advantage is that you're able to not have the application have to go dig in Active Directory to pull out other information. It's all supplied in the claims. So that's nice. But the other huge advantage, and I would argue this is probably bigger in most cases, is that the app can now be used in other identity contexts, which I'll show you next, without any changes. You've built an app that can be used more effectively in a broader range of scenarios without being changed. I don't know about you, but my experience is when you build apps, you can just never know what's going to happen. And people so often ask you to do stuff you hadn't planned for originally. So suppose, for instance, that somebody asked you to now make this app accessible on the internet. Well, how do you do that? In this case, you might do it like this. You can have the user on the internet now do the same thing. They go to the app, they get the requirements, again, via HTML, or if it's a SOAP call with WS security policy. The user chooses an identity with CardSpace. They then go to, CardSpace goes to a Geneva server, gets the token, submits the token, and the app uses the claims. Notice this. The app didn't change. The app is just the same. It doesn't care how the user authenticated. It doesn't care. But how did the user authenticate? In step 3, what actually happens there? How does the user authenticate? With the Geneva server, there are several possible answers. You can use Kerberos, mentioned earlier, but Kerberos is not necessarily the right choice, maybe with a VPN. But for internet use, Kerberos isn't always the best choice. Geneva server supports username and password. You can use that. You can use Smart Card with Geneva server. You authenticate somehow. And so maybe you're thinking, well, wait a minute. Username and password. You tell me I still have usernames and passwords on the internet? Well, what's wrong with this picture? Brief digression here. Username and password is about the weakest way one can imagine to authenticate, right? People use the weakest authentication mechanism, username and password, in the most threatening environment, the internet. This makes roughly no sense, right? Although with SSL, okay, it's a better solution. The challenge really is phishing. Phishing is the huge issue, where people convince users to give them username and password. So you're thinking, we still have username and password. How is this better? I'll tell you how it's better. Who is getting username and password here? The app? No. The STS. How does CardSpace find the STS? From a URL supplied by the app? No. By configuration buried in the client. A phisher cannot give you their own URL and say, give me username and password. You can't do it. You go to the STS instead. And apps are no longer maintaining their own databases of usernames and passwords. I hope you're thinking, oh, beauty. There's some beauty here. This is progress, I think. This is definitely progress. Oh, one more thing. If that user is an employee of the company, then they probably have an account in Active Directory. So life is simple. But suppose this is a public site. Suppose Amazon did this, for example. Well then, what are you going to do? Are you going to add all of your customers to Active Directory? Gee, most folks don't want to add outside users to their internal domain AD, right? For some very good reasons. So what do? Well, one option is to build a separate AD forest, say in the DMZ, that contains your external users. Still use AD, but do a separate forest in your DMZ, for example. You can do that. Or for at least some of the information, you can use SQL Server or Active Directory Lightweight Directory Services, ADLDS, formerly called ADAM, Active Directory Application Mode. You can use ADLDS to do this, but it turns out you still need Active Directory for some aspects of it. Or you can build your own STS. You can build your own STS that uses its own store. Geneva Framework, as we'll see, helps you do that. So there are various options there. How about this? Now let's assume that your application decides to trust some external provider of identity. Like who? Well, the most visible in our world is Windows Live ID, the former Passport. But there are others potentially too. Let's suppose your app is going to trust identities issued by that identity provider's STS. How does it work now? Well, by this time, I hope you can almost draw this picture yourself. Because what happens? The app, the client, goes to the application, learns what it needs, chooses an identity, goes to that provider. In this case, it's not Windows Live ID, it's the other one. Gets the token, submits it. The app in Geneva Framework has to check that token signature against its list of trusted STSs. We assume it trusts this one here. It said it did in step 1, and it uses the claims. Once again, what is so beautiful here for you, the app developer, is your app has not changed in any of these scenarios. Hasn't changed at all. It just gets a token with claims. Thank you. Life is simple. Life is good. You know, when CardSpace first came out, there were endless press articles that told us that CardSpace was Microsoft's attempt to rescue the successor to its failed Passport technology. Did you read those? Those drove me nuts. Because first of all, Passport didn't fail. Now it's called Live ID. But second, look at this picture. Look where CardSpace sits. Look where Live ID, the former Passport, sits. They play totally different roles. So those arguments that CardSpace was the new Passport were just totally misguided. I got to tell you, though, I had multiple conversations with the trade press people about that. Think about this. We've spent 45 minutes getting to this point, and you're professionals in the field. To explain this to a reporter was very difficult. On the phone in 5 minutes, it was very hard. Not that they're dumb. They're not dumb. It's just a hard problem. So there was some confusion there. But if you've ever seen that confusion, please be clear. These things are very different. All right, next scenario, next problem. What if I want to do identity between organizations? Here's the situation. Suppose that a user in one Windows forest, say one company, needs to access an application in some other Windows forest. Or suppose that only one side runs Windows, one side is not Windows, uses something else. Of course, both could be non-Windows as well. This is a Geneva talk, which is Windows only. So the point is, the problem is much the same, whether they're two Windows forests or Windows forest and a non-Windows world. Example. Suppose, a canonical example here. I want to give a SharePoint site in your company, make it accessible to users in my company. How do I do that? Or another common example, maybe the firm you work for has retirement accounts it maintains for you at a firm like Fidelity or Vanguard or someplace else. How can you access those accounts from your work environment? They're separate worlds. What are the possible answers? Possibility number 1, just create duplicate accounts. Just create accounts in the other environment, the other world, for your users. Simple. Straightforward. And really, really unpopular. Nobody likes this because users have a separate login and password to remember that they've got to log in with. They hate that. Administrators hate it too because when you give users logins and passwords, they forget them. And they've got to deal with this stuff. They've got to maintain all these accounts for users in their customers and other organizations. And, maybe worst of all, suppose I work for a company and I have access to some SharePoint site, for example, over your company. I've got an account for it. And suppose I quit. Or worse yet, suppose I'm fired for some kind of nefarious behavior. When I'm fired, I'm out of my AD right away, right? How long before your firm figures out that I was fired for lying, cheating, and stealing and removes my account from your world? The answer might be never, but it surely is not right now. And that's a problem. So duplicate accounts work, but nobody likes it. Users don't like it, admins don't like it, security guys don't like it. It's just not a great solution. A better solution, in the minds of most people, is what's called federation, identity federation. The notion here is that I get that other organization to accept identities issued by my world, by my provider. We federate to get them to trust me. So stuff I issue can be used, we'll see some changes possibly, in their world. What's great about this? No duplicate accounts, single sign-on. Admins love it, users love it, life is good. Is it perfect? No, of course not. Because what's really happening here? What's really happening is that company is saying they're trusting my company to correctly issue identities. What if I screw up? What if I screw up and something bad happens to their data? Whose fault is that? Turns out that when people do these federation agreements, the technology, I'll show you in a moment, is pretty straightforward. They can spend months on the business agreements. So realize that federation requires sometimes contentious and painful business discussions. The technology issues are solvable. The business issues can be painful. Just be aware of that. How does this actually look in the Geneva world? Well, the answer is a couple of possibilities. Here's the simplest one. Let's suppose that I have organization X in which the user resides, organization Y in which the app they want to access resides. That could be anything, custom app, SharePoint, whatever you like. Okay? Notice, there's an STS in both apps. I'm sorry, in both worlds. In both worlds. But notice something else. The lower right-hand corner there, the application has a list of trusted STSs. Which STSs will it accept tokens from? In my simple case here, it trusts the STS in its own organization, organization Y, of course, that's obvious. But in this case, that app has also been configured to trust the STS in organization X on the left. If that's the case, this process is pretty straightforward. Here's what happens. The client goes to the app, says, what do you need? You go back to the client, who chooses an identity that matches that. Once again, step 2 might be omitted with configuration stuff, but I'm always showing it in all these slides explicitly. You then go to the STS in X, authenticate yourself, get the token, and you supply it to the app. The app checks the token. It is signed by STS X, which it trusts. It's on its red list there. So it happily just uses the claims. Life is simple. It's very straightforward. If the app directly trusts the STS in the user's world. Is that common? No, it's not. Because it's a pain. If you have a bunch of apps in organization Y, they've all got to be configured to trust STS and X. And if organization Y has a bunch of apps that federate with a bunch of other domains, oh, what a pain that's going to be. All the apps must be configured for all the, oh, yuck. It's horrible. Right? This works, but it's simple and not really very effective in most real situations. I wanted to start here because it gets the idea across. But here's a more realistic situation. In a more realistic situation, the application only trusts its own STS. As you see in the lower right-hand corner, its list of trusted STSs includes only organization Y. That's it. But notice now, in the upper right-hand corner, that the STS in Y itself trusts the STS in organization X. What does that mean? What it means in a pragmatic sense is that that STS has a certificate for the STS in Y, and thus can check the signatures on tokens that X issues. How did it get there? Administrators did this. People did this. People created this trust relationship. In this scenario, here's how things go. Take a deep breath. This is the most complex diagram in my talk here this morning. So here we go. The client accesses the app in Y. The app says, you know, I only trust my own STS. You must get a token from my STS to talk to me. So the user then goes to that STS. It says, hey, STS, I want a token for this app. Hey, by the way, I got to show you this. My picture is misleading. My picture shows that step number 2, coming from your app, in fact, it's CardSpace that does this, not your app. CardSpace does this transparently for you. Didn't fit my picture very well, but trust me. CardSpace knows how to walk a federation tree like this. So CardSpace goes to the STS in Y and says, I want to talk to this app. Give me a token for this app. And the STS says, nope, I will not do that until you give me a token from the STS I trust in organization X. All right, so then there's that possibly, that identity selection step, and then you get a token from your own STS. This token, as always, you authenticate to get, probably with Kerberos in this scenario, as I showed you earlier. It's a token not for the app, it's a token for the STS in Y. You present that token to the STS in Y. It checks the signature. It says, yes, this came from X. I trust X. Therefore, I will issue you what you want, a token for the application. That token is signed not by the STS in X, by the STS in Y. The app gets the token, checks the signature, says, yup, it's signed by Y. I trust Y. I'll use the claims. There you have it. Federation in the brave new world of claims-based identity. Notice a whole bunch of things here. Notice once again this point I keep on making over and over. No matter what falderall, complexity, challenges we're putting on the authentication side, the app always stays the same. The app doesn't care. The app, in fact, is unaware of all this crap going on. For app developers, this is a beautiful thing. If you're an administrator, maybe you're thinking, well, okay, you're pushing complexity off to me, aren't you? Well, yeah, kind of. This is the architecture track. It's for the dev part of the conference, so we're okay with that, right? That was a joke if you're an administrator. Not a very good joke, I see, right? But, you know, complexity you can run, but you can't hide. It doesn't go away. But getting it out of the apps, putting it in a centralized place, the STS, I think makes a great deal of sense. Putting it in one place. Notice something else. In step 5, the client submitted a token to the STS. That token contained claims that were required for this app. How in the world did the STS in organization X know what claims this app in Y wanted? How did it know? The answer is an administrator told it. It was configured that way. And you're thinking, oh man, that's painful. He said this was beautiful. That isn't beautiful. No, you're right. You're right. But all beauty has, you know, flaws as well. How else are you going to do it? How else can you do it? And think about this. This is where claims really shine. Because if I didn't have claims here, then potentially my app in Y would have to go back to Active Directory in X and query information. Is that possible? No, probably not. And so claims let the app in Y get what it needs without having to try to query this foreign directory, which couldn't do anyway. And now one more key thing. Look at what's happening between steps 5 and 6. In step 5, Y's STS gets a token that contains some claims, signed by X. In step 6, it issues a token containing some claims, signed by Y. Are the claims in those two tokens, one received in step 5 and sent in step 6, the same? The answer is maybe. Maybe. Or maybe not. Because STSs can do this thing called claims transformation. Claims transformation. Where a token can arrive with one set of claims and go out with another set of claims. There is in the Geneva server a rules language for defining how those transformations happen. So for example, if you do what I said earlier, I talked about this idea, the ability to have a claim represent the right to do something. The presence or absence of the claim could be interpreted by the application as the right to access this data, invoke this method, whatever. If you do that, you can define the rules that insert or remove that claim in the Geneva server, in the right-hand STS, if that were Geneva. You can do access control up there in a centralized place with rules. It's interesting. And by the way, quick aside, anybody familiar with this thing called .NET Services Access Control? It's part of the Azure Services Platform. If you are, what that effectively does is takes an STS, much like the one in the upper right-hand corner here, puts it in the cloud. It's much like putting the resource side STS in the cloud. That's what ACS is. It's a rough approximation anyway. If you were in my Azure talk earlier, and I skipped over describing what ACS was, this is why, people. Because to explain it required all this stuff. So that's why I don't do it in 5 minutes in the Azure talk. All right. We're almost done. One more scenario. Delegation. Suppose I've got this situation. Suppose my user, has gotten a token for application X. Excuse me, I'm sorry. Again, let's assume they did that in the usual way. I'm going to leave all that out for this picture, but they did what we showed earlier in these diagrams. Now, they want to access X. They submit the token to X. Let's suppose X is a browser app. It's a web app. Through a browser, they're talking to app X with a token for X. Now, suppose that application X, to carry out the request I'm making of it, must invoke a web service in application Y. Suppose further that app Y wants to make an authorization decision based on who I am, who the user is. That's pretty normal, right? This requires that X be able to make a request to Y in my name, as if it were me. This requires what's commonly called delegation, a way to delegate my identity information to X to pass on to Y. Can you do that here? Yes, you can. Here's how it works. X will access Y, as always, learn its requirements. It will then go to an STS that Y trusts. In this scenario, I'm assuming X and Y trust the same STS. They don't have to, but it makes my picture simpler. Application X goes to its STS. It says, I'd like a token for app Y. Here is the token for X from this user. It makes a request that really says, I want to delegate. I want a token for Y that contains this user's information. Geneva Server has policies defined administratively that let it check for this user, is app X allowed to get a delegated token for app Y? If the answer is no, it rejects the request. If the answer is yes, as in this situation, it will create a token for Y with information for this user. Are the claims in that token identical to those in the original token? Maybe, maybe not. It's a token for app Y. So app Y might want different claims. It's possible. We get this token, and app X now submits it to Y. Y does the usual checks. It trusts the STS. It uses the claims. What is beautiful about this? I'll tell you. What's beautiful about this is that Y only gets a token that lets it act as me for this one thing. And X can only act as me for this one thing. A more common way today to do delegation is to make X into what's commonly called a trusted subsystem, where I talk to X, tell it who I am, and X then has the right to do all kinds of things for all kinds of users because I trust X not to behave badly. This is bad. DBAs hate this. If X is trying to access the database and you give it full access, DBAs just hate this, in my experience. And also, if you want to audit who accesses what in the Y level, you can't see it anymore. You lose the user. So this is actually very nice for that scenario as well. It's probably evident. But can you tell how much I love this stuff? And come on, tell me. We're almost done here. Are you starting to share my love? Are you starting to see the beauty inherent in this technology? Please nod your heads. Thank you. Thank you so much. My day has not been wasted. All right. Let's just end here with a quick look at some of the Geneva technologies. Not too much left. Geneva Server, I told you earlier, is the next release of ADFS, Active Directory Federation Services. But it's quite different. It's quite different. Because ADFS supports only what identity guys call passive clients. That means web browsers. With this protocol called WS Federation. And there's no real STS in ADFS. It does not support WS Trust. You can't get SAML tokens. It's not really an STS. Geneva Server supports active and passive clients. That means web browsers and rich client apps with web services or other things. Geneva Server, as we have seen, has an STS built into it. Geneva Server supports WS Federation, the older approach, and it supports the SAML 2.0 protocol. Remember I told you, SAML is a token format that's long been used in this world, and it's also a protocol. Turns out there has been this long battle between mostly Microsoft and mostly Sun about WS Federation versus SAML for browser-based single sign-on, the SAML protocol. Microsoft was adamant, WS Fed is the answer. The SAML protocol is the evil work of the devil. Okay. With Geneva Server, Microsoft has actually embraced the SAML protocol. If you're brand new to this space, you're saying, yeah, and so? But I'm telling you, among that Burton Group cognoscenti bunch I talked about earlier, when this fact was announced, oh, the heavens opened. It was a glorious thing. This is the new Microsoft, man. This is not the old Microsoft. I was very impressed they did this. Made sense to me. Some more changes. Geneva Server automates some aspects of trust management. So, for example, I told you that what trust means is that one STS has a cert for the other one. Certs expire. When the cert's going to expire, it can actually see this, automatically ask for a new one for its partner. So it makes administration somewhat easier in some scenarios. What about card space? I've told you throughout this talk that card space, as identity selector, provides a user interface that lets users choose identity. I've not shown you what it is. Well, there it is. There's an example of a card space screen. The user chooses a card, and the card represents an identity. Turns out that there's more going on here than you might think. Because here's what really happens. Behind the card is this thing called an information card. It's kind of confusing. Because the card is the GUI thing the user clicks on. An information card is an XML file. The information card contains what's needed for card space to go to the right identity provider and find this identity. What it does not contain, this is really important, what it does not contain is any claims or any authentication information. All the information card contains is what's needed for card space or another identity selector to find the identity provider, the STS, for this identity. What that means is they don't need to be secret. There's a web page you can go to for Geneva Server and get these things. It's straightforward. They don't need to be secret. Because if I have your information card, I still can't use it unless I know your password or whatever to authenticate to the STS. That's really important. Here's a picture. I'm showing card space Geneva there. You might have in your system some number of information cards. There's one that's bound to an identity in the rightmost STS with that identity provider. Another one here is bound to, let's say, some other identity, the same provider. That's possible. You might have identities that have different information in them based on what you want to provide to a given application. And you might have other cards that are bound to identities of other providers. Remember once again also that it is possible in this brave new world of Geneva to configure card space such that you do not have to see the screen pop up. So these choices are made by configuration, and this happens under the covers. That can make life simpler for users in at least some situations. What's different in card space Geneva? We'll see some interesting things. Before we do that, one more point worth making here. There is this thing called the Information Card Foundation, a multi-vendor group that exists to make information cards a cross-vendor successful technology. Look at the board members. I told you earlier this was not just a Microsoft endeavor, and it is not. It is not. These guys have defined a little icon that can appear on a website to indicate that the site accepts logins that are information card based. So, we don't see this too much yet, but we're starting to see it. This version of CardSpace has a few changes. A big one is it's no longer built on the .NET framework. That makes it smaller and faster. Not a bad thing. It also, as I've said several times, has optimizations. I've mentioned one of them. There are others as well. So a website, for example, can itself display the card you use to last log in. There are various optimizations to help make life easier for users, so they need not choose a card every single time. And one more point here. If you are following CardSpace, if you knew the old version of CardSpace, CardSpace had this thing called the Self-Issued Identity Provider. It's very interesting. It's a very cool idea. It was an STS that ran on your desktop that issued identities, tokens actually, that you could submit to websites, for example, to replace username password. Interesting aspects, interesting stuff there. Would help with phishing. But it wasn't used very widely, at least thus far. And for various reasons, it's been dropped from Geneva. Will it reappear at some point? Maybe. I don't know. But it's not in Geneva. And then finally, the Geneva Framework. This library whose goal is to help developers create claims-aware applications. It was called Zermatt originally. It was then renamed. If you see Zermatt, it means the same thing. It's got some pretty basic stuff. It makes this really quite straightforward. If you were in the earlier talks, they demoed this guy, and man, it makes it really straightforward. It's not a complex thing at all. It gives you built-in ways to verify the signature, pull out the claims, gives you a class to work with the claims. You can, if you want, build a custom STS on this framework. As a matter of fact, the Geneva server itself is built on the Geneva framework. So you can do that. Some final thoughts here. You know, the technologies that we use today for identity, Kerberos, username, password, the federation stuff, have grown up over decades. They are the accretion of solutions we've seen over a long period of time. As you've seen here, to a large degree, this new approach does not get rid of them. It builds on them to do things more intelligently, changing how users with CardSpace, possibly, administrators with Geneva Server, and developers with Geneva Framework do identity is not a small thing. It is not a small thing. And so Microsoft tells us this will all ship by the end of the year. Beta 2 shipped this week. It'll be available in full release, they say, by the end of 2009. Do I expect by mid-2010 that Geneva and this approach will be ubiquitous? Of course not. This is not a short-term solution. But in the longer term, having these things available on Windows, they're all part of Windows. There's no extra cost here. They're all part of Windows. Having these guys available on Windows, I think, will go a long way toward making this idea of claims-based identity real. And you know what that means? That means that in, I think, a deep and fundamental way, the world is going to get a lot more beautiful. Thank you very much. All right, I'm out of time. So if you have questions, please come to the front. And remarkably, we have Vittorio and Caleb from Microsoft to help answer very detailed questions as well. So come up and ask whatever you'd like. Thank you.